Welcome, curious minds, to the deep dive. Today, we're plunging headfirst into the incredibly complex, ever-evolving world of modern industry.
It really is complex, isn't it?
Absolutely, think about it. Massive factories churning out everything from microchips to medicines, intricate energy grids that power entire cities, even the colossal ships navigating our oceans. They are all humming with an astonishing number of interconnected systems.
Uh-huh.
The big question, the one that truly keeps engineers, innovators, and business leaders up at night is, how do we make these intricate, often rigid systems not just smarter, but truly flexible, adaptable, and significantly easier to manage?
Right.
Not just for today's rapidly changing demands, but for the decades of technological innovation ahead.
That's a profound challenge, and it really underscores the urgency for new approaches in industrial control. The traditional methods, while robust in their time, they're struggling to keep pace.
Certainly, how exactly?
Yeah. With the demands for agility, real-time responsiveness, and seamless integration that modern industry now requires, we're seeing a fundamental shift in what's expected for automation.
Absolutely. A fundamental shift indeed. And that brings us directly to our mission today. We're embarking on a deep dive into a crucial, yet perhaps less widely known outside of specialized circles, technological standard.
Mm-hmm.
It's quietly but profoundly revolutionizing industrial automation. IEC 61499.
That's the one.
For this deep dive, we've had the unique opportunity to sift through the agenda and the comprehensive overview of a truly significant gathering, the WSO3 Advancing Industrial Automation, Best Practices and Innovations with IEC 61499 workshop.
Yeah, that's a key event.
This pivotal event is happening as part of the prestigious IE International Conference on Emerging Technologies and Factory Automation, or ETFA 2025.
It's a goldmine of cutting-edge information and insights. This isn't just a casual industry meeting. It's a full-day workshop meticulously structured around invited presentations from leading global experts.
A full day, wow.
Yeah. This format alone signals a deep, comprehensive, and authoritative discussion specifically designed to push the boundaries of what's possible with IEC 61499.
Our mission today, then, is to meticulously extract the most vital insights from that workshop. We aim to make sense of how this powerful standard is being discussed, developed, and applied by the absolute forefront of experts and organizations.
Basically boiling it down.
Exactly. Consider this deep dive your shortcut to genuinely understanding the next wave of industrial control. By the end of our conversation, you'll not only understand the core concepts of IEC 61499, but you'll also know the key players driving its adoption.
Which is really important.
And perhaps most importantly, you'll grasp its profound implications for everything from precision manufacturing right through to the complex, safety-critical operations found in the maritime industry.
Our goal is to connect all these dots for you, showing not just the technical what of this standard, but the crucial why it matters so much, and how it's shaping the very future of how goods are produced, how energy is managed, and how industries operate on a global scale.
Okay, sounds like a plan. So let's unpack this and start with what we're calling the very DNA of flexible automation, IEC 61499 itself.
Good starting point.
To begin, let's peel back the layers on IEC 61499. What exactly is this standard that's causing such a stir? At its core, it's an international standard. Specifically, it's an international standard for something called function blocks,
Function blocks, right.
used in industrial process measurement and control systems. That sounds a bit technical maybe, but I think the concept itself is really quite elegant, isn't it?
It is, because a function block, at its essence, is a self-contained, reusable software component. Think of it like a highly specialized, intelligent Lego brick.
Okay, a Lego brick, I like that.
Yeah, each brick is designed to perform a specific well-defined task, say, controlling a motor, reading a temperature sensor, managing a specific step in a manufacturing process, or even executing a complex algorithm.
Got it. So little bundles of capability.
Exactly. And the genius of IEC 61499 is that it standardizes how these bricks are designed, how they behave, and crucially, how they communicate with each other.
Ah, the communication part is key.
It is. This allows you to easily snap them together, often visually, to build complex automation logic, regardless of the underlying hardware or the vendor.
Regardless of the hardware, that's a big deal.
Huge deal. It decouples the software logic from the physical devices.
That's a powerful distinction. And while traditional industrial control methods like ladder logic,
Right.
which many listeners might know,
Yeah, very common.
have served us incredibly well for decades, they are often very sequential, very linear in their execution.
Yeah.
You typically move from step A to B to C in a fixed order.
Right. rung by rung.
And the entire control program often processes through its cycle, regardless of whether specific inputs have changed or not. It's like a meticulously choreographed play that always runs to the end, even if one actor has no lines in a particular scene.
Precisely. Ladder logic is fundamentally synchronous and state-based. It operates on a fixed scan cycle where it reads all inputs, executes the logic sequentially, and then updates all outputs.
Okay.
While incredibly robust and predictable for many applications, this can lead to inefficiencies in complex dynamic systems. IEC 61499, by contrast, introduces a fundamentally event-driven paradigm.
Event-driven, what does that mean in practice?
It means that function blocks only wake up and execute their logic when a specific event occurs, a sensor input changes, a timer expires, or maybe a message is received from another function block.
Ah, so they only work when they need to.
Exactly. This makes systems far more responsive, efficient, and importantly, modular and reusable. It allows different parts of a system to communicate and act truly independently based on specific conditions and triggers rather than a rigid, universal clock cycle.
So for you listening, if you were to visualize this paradigm shift, you mentioned Legos.
Yeah.
Maybe think of it like moving from a rigid, monolithic computer program where every single line of code is tied together and has to run in a specific, predetermined order.
Yeah, like old mainframe code sometimes.
Yeah, to a modern system built more like a collection of apps on your smartphone. Each app can easily talk to others, launch when needed, and adapt to new situations or even new hardware without requiring a complete overhaul of the entire system.
That's a great analogy.
You can even sort of drag and drop new functionality in some tools. It represents a huge leap in how we design, manage, and ultimately scale complex industrial processes.
And this inherent modularity, reusability, and event-driven nature are precisely why the workshop overview explicitly states IEC 61499 is gaining traction in the industry.
Gaining traction.
This traction isn't accidental or a fleeting trend. It reflects a growing and increasingly urgent need for agility, flexibility, and adaptability in manufacturing and across virtually all industrial processes globally.
I see. So this isn't just about a better technical standard on paper. It's about addressing fundamental business and operational pressures that companies are facing today.
Absolutely.
What kind of pressures are we talking about?
Well, think about what modern companies are grappling with. They need to reconfigure entire production lines faster than ever before to meet fluctuating market demands.
Right. Faster changeovers.
Exactly. They have to integrate new, often disparate technologies like advanced robotics, AI, sophisticated vision systems, seamlessly and quickly.
That integration piece is tough.
Very tough with older systems. Furthermore, they are managing increasingly distributed systems, often spread across vast geographical areas or across different facilities, far more efficiently than traditional, centrally controlled methods allow. The rigid, older approaches simply cannot keep pace with this need for rapid dynamic change.
So this standard directly addresses some of the biggest challenges associated with what we broadly term Industry 4.0, the fourth industrial revolution, which is all about smart factories and connected enterprises. Could you expand on that connection a bit?
Certainly. Industry 4.0 pillars like the Industrial Internet of Things, IoT, where countless devices generate and exchange data, rely heavily on flexible distributed communication. IEC 61499 provides the ideal framework for these devices to communicate intelligently and independently.
Okay.
It also fundamentally supports the demand for personalized production, where batch sizes can be incredibly small, sometimes even just one item.
Batch size one, yeah, the holy grail.
Exactly. Traditional systems, with their rigid sequential logic, would grind to a halt or require immense human intervention for such rapid changeovers. IEC 61499, with its modular and event-driven architecture, allows individual workstations or robotic cells to be dynamically reconfigured or even swapped.
Swapped out. Like physically?
Potentially, yes, or at least logically reconfigured very quickly.
Yeah.
This enables what we call mass customization, producing customized items at scale without sacrificing efficiency or incurring prohibitive costs.
That's huge.
Its distributed architecture also allows for greater resilience. Parts of a system can continue functioning even if other parts experience issues, which is crucial for overall system stability and scalability.
So what does this foundational shift ultimately mean for you, our listener? Beyond just smarter factories, how does this translate into tangible benefits for the everyday consumer or even the broader economy?
Well, consider the current complexities and vulnerabilities in global supply chains we've all experienced.
But yeah,
A factory making household appliances, for example, might currently take weeks or even months to retool for a completely new model or to pivot its production to meet an unexpected surge in demand for a different product.
right. Long lead times.
With IEC 61499's inherent agility and modularity, that retooling time could be drastically reduced to days or even mere hours.
Hours. Right.
That's the goal, the potential. This directly impacts you, the consumer.
Yeah.
New and improved products can hit the shelves faster, companies can respond to trends and disruptions more quickly, and the efficiencies gained in production could even translate to more stable or potentially lower prices for the end user, especially for customized or short-run products. It's about creating a supply chain that bends, not breaks, under pressure.
Making industry more resilient and responsive, which benefits everyone.
Exact.
That's a powerful connection to our daily lives. Now that we've outlined the profound capabilities of IEC 61499 and why it's gaining such significant traction, it's clear that a powerful standard only truly comes alive when brilliant minds converge to develop and apply it.
Uh-huh. The human element.
That brings us to the very heart of our deep dive today. This pivotal workshop, a true nexus where academia and industry are shaping the future of this technology.
Indeed. The WSO3 Advancing Industrial Automation, Best Practices and Innovations with IEC 61499 workshop is scheduled for September 9th, 2025. It's hosted as part of the prestigious 30th IE International Conference on Emerging Technologies in Factory Automation, or ETFA 2025.
ETFA 2025, and IEC, that lends a lot of credibility.
Absolutely. The very fact that it's hosted by IE, which is the world's largest technical professional organization dedicated to advancing technology for humanity, and that ETFA is celebrating its 30th iteration.
30 years.
Speaks volumes about the event's gravitas and its position at the forefront of industrial innovation.
It really does. That 30th iteration shows a long, consistent history of innovation, indicating a deep and sustained commitment to staying at the absolute cutting edge of industrial automation research and development.
It's not a flash in the pan.
No, this isn't a niche gathering. It's a critical forum where the leading minds in the field come together to truly shape the future direction of the industry.
And the workshop's core mission further underscores its significance. Its goal is explicitly stated to foster interaction between academia and industry, enhancing knowledge exchange on IEC 61499.
Academia and industry, that's key.
And to be pivotal in advancing collaboration in this field. It also aims to engage more industry professionals to share use cases and best practices, building on the success of the 2024 workshop in Padova.
Ah, so there was one last year too, in Padova.
Yes, indicating this isn't a one-off event, but part of a sustained effort, showing growing momentum.
Okay. I'm particularly interested in that bridge-building role between academia and industry. How crucial is that synergy for a standard like IEC 61499 to truly take hold and succeed?
That synergy is absolutely essential, and I'd argue it's the lifeblood of technological advancement in industrial settings. Academia often provides the foundational theoretical advancements, the long-term vision, the initial research that pushes conceptual boundaries.
The what ifs.
Exactly, they explore what's possible. However, without industry, this research can remain purely theoretical, detached from practical realities.
Right, stuck in the lab.
Industry brings the real-world challenges, the practical application needs, the scalability requirements, and the crucial validation of whether these theories actually work reliably in the grit and grime of a factory floor, across a vast energy grid, or within a complex maritime vessel.
Okay, so grounding the theory.
Precisely. That Padova mention shows there's a clear and increasing demand for this kind of focused, collaborative discussion year after year.
So for you, our listener, this dual focus means you're not just hearing about abstract theories that might sound promising in a lab, but about how these brilliant ideas are actually being put to work.
Yeah, the practical side.
The specific engineering and operational challenges being overcome, and the measurable benefits being achieved in real-world industrial settings. It's about direct impact.
Mm-hmm.
And speaking of collaboration, the architects behind this workshop are a fascinating mix of talent. The co-organizers are Eloise Eutel from J.K. Willents,
Top academic in the field.
Valerie Viatkin from LTU and Alto,
Another leading researcher,
Franco Cavadini from GR3N,
bringing that industry application view,
and Ina Arkhipova from universalautomation.org.
representing that crucial broader initiative.
That diverse group is highly significant because it represents a truly comprehensive ecosystem approach, doesn't it?
It really does. We have leading academics like Zoidel and Viatkin, critical for fundamental research, developing advanced concepts, and educating the next generation of engineers.
Right.
Then we have the vital industry perspective represented by Franco Cavadini of G3N, bringing invaluable insights from real-world application, deployment challenges, and commercial viability.
Makes sense.
And finally, Inna Arkhipova from universalautomation.org, representing a major independent initiative specifically dedicated to the broader adoption, standardization, and community building around these technologies.
It's like assembling an all-star team, each member bringing a unique, indispensable piece of the puzzle.
That's a good way to put it.
This blend of institutions and perspectives speaks directly to the broad impact and inherently interdisciplinary nature of industrial automation today. It demonstrates that pushing a standard like IEC 61499 forward
Yeah.
from theoretical concept to widespread industrial implementation requires not just technical brilliance, but also strategic vision, robust research, and a profound commitment to fostering a wide-ranging, collaborative ecosystem.
Precisely. Each co-organizer offers a unique, vital perspective, ensuring that the discussions at the workshop are well-rounded, grounded in both cutting-edge research and practical industrial demands, and ultimately accelerate the standards progression.
Okay, so let's delve deeper into some of the key drivers and foundational infrastructure that are making this future a reality. At the heart of driving discussions around IEC 61499, and indeed championing a broader vision for industrial automation, is universalautomation.org.
Right, we mentioned them.
Greg Bucco from this organization will be providing an introduction to what they're all about at the workshop.
Yes, the workshop overview clearly highlights universalautomation.org as driving discussions around IEC 61499. This immediately signals their central and highly influential role.
So what is universal automation as a concept?
Well, to clarify for our listeners, universalautomation.org is an independent, nonprofit organization that's actively building a global community around a compelling vision of universal automation. What that means, at its core, is a future where industrial automation is truly open, universally interoperable, and fundamentally software-centric, not tied to any single vendor's proprietary ecosystem.
Breaking the vendor lock-in.
Exactly. They are advocating for a new era where industrial control systems are as flexible and adaptable as the best IT infrastructures.
That sounds like a powerful counter-narrative to the traditional model, which often sees companies locked into one vendor's proprietary systems, making integration and upgrades incredibly complex and expensive.
Is.
How vital are organizations like universalautomation.org in preventing that kind of vendor lock-in?
They are absolutely vital. In any industry, but especially in technology, vendor lock-in can stifle innovation, increase costs, and limit a company's agility.
Right.
An initiative like universalautomation.org acts as a unifying force, helping to prevent this by championing common open standards like IEC 61499. This allows different companies and developers to innovate on a shared open foundation without fragmenting the ecosystem.
So everyone plays in the same sandbox, basically.
Right. In a way, yes. It accelerates innovation across the entire industry because everyone can contribute to and build upon the same infrastructure. They ensure that the focus remains on open, interoperable solutions rather than proprietary control.
So, in essence, they act as the orchestrators, ensuring that everyone involved in industrial automation is working from the same blueprint, moving towards a future of shared principles and open collaboration.
Exactly. They facilitate collaboration rather than competition in fundamental infrastructure, which is a significant shift in mindset for a historically competitive industry.
Yeah, that is a big shift.
Yeah.
And speaking of foundational infrastructure, a major player in this open ecosystem, which also comes up early in the workshop agenda, is Eclipse Fortiac.
Yes, Fortiac. Very important.
Bianca Weismeyer from JKU will be presenting on building an open-source infrastructure for IEC 61499 research, technology evaluation, and standardization, 18 years of experience with Eclipse Fortiac.
18 years.
18 years. The workshop overview even calls it an open-source infrastructure for research, technology evaluation, and standard development.
The 18 years of experience immediately leaps out as profoundly significant. In the fast-paced, often fleeting world of software and technology, 18 years is practically a lifetime.
It really is.
This demonstrates an incredibly sustained commitment, a remarkable level of maturity, and proven stability for an open-source project. It signals that this isn't just a recent initiative, but a deeply entrenched, community-driven effort to build robust, foundational tools that have stood the test of time and continuous development.
It's a huge testament to its stability and ongoing relevance. And the power of open source in technology adoption, especially for something as complex as an industrial standard, is immense, isn't it?
It's transformative. We're talking about rapid iteration because you have a global community contributing to the code base, identifying bugs, and proposing new features much faster than a single proprietary team ever could.
More eyes on the code.
Exactly. You get transparency, which builds trust and allows for rigorous peer review. And crucially, it's often far more cost-effective than proprietary systems, drastically lowering the barrier to entry.
Lowering the barrier.
Yeah.
How so?
For researchers, smaller companies, and even individual developers who want to experiment, learn, and innovate with IEC 61499, it democratizes access to this technology. You don't need expensive licenses just to start exploring.
Right. So this robust open source platform accelerates the adoption and refinement of a standard like IEC 61499 by providing a tangible, accessible, and collaborative environment.
Precisely. It transforms what might otherwise be an abstract, complex specification into a tangible, usable, and continuously evolving framework. Eclipse 40ac acts as a vital laboratory and proving ground,
A proving ground, okay.
allowing for broad experimentation and diverse contributions, identifying potential issues and innovative solutions much faster than a closed proprietary development model. It's an engine for both academic exploration and practical industrial application, pushing the standard forward in a very dynamic and practical way.
Okay, so we've covered the foundational standard IEC 61499 itself and the key organizations like universalautomation.org and tools like Eclipse 40ac driving its adoption. Now, let's transition from those drivers and infrastructure to, well, Section 4, bridging theory, to practice applications in engineering.
Where the rubber meets the road.
Exactly. This is where we start to see how IEC 61499 moves from concept to concrete implementation, solving real-world industrial problems. A key area for application is in open process automation systems, or OPAFs.
OPS, yeah.
Pranay Shunshwala from Alto will discuss the use of IEC 61499 in open process automation systems applications.
This is a particularly exciting convergence. To understand its significance, it's helpful to briefly define open process automation, or OPA.
Okay, what is OPA?
OPA is a major industry initiative driven by consortiums like the Open Process Automation Forum, OPF, with the explicit goal of transforming traditional process control systems. Historically, these systems have been characterized by highly proprietary, monolithic architectures,
Right, the big lockdown systems.
leading to vendor lock-in, high integration costs, and limited flexibility. OPA aims to create systems that are truly more modular, interoperable, and inherently secure, moving away from these constraints.
And IEC 61499 fits in how?
Its distributed, event-driven, and modular nature makes it a natural, almost perfect architectural fit for OPA initiatives. It provides the foundational language and framework for this ambitious vision.
That sounds like an incredibly powerful vision for modularity and process control. But practically, how significant are the hurdles to achieving this full convergence in existing industrial plants? Are we talking about a complete rip and replace or more of a phased integration?
That's a crucial and very pragmatic question. For many existing industrial facilities, a complete rip and replace is often, well, it's just not economically or logistically feasible.
Too expensive, too disruptive.
Exactly, due to the immense capital investment and potential downtime. So the focus is largely on phased integration, creating hybrid systems where new OPA-compliant modules, often running on IEC 61499, can interoperate with existing legacy systems.
Okay, hybrid systems.
But the hurdles are significant. We're talking technical challenges, ensuring seamless communication and data exchange between disparate protocols, but also cultural and organizational ones.
Cultural, how so?
It requires a shift in mindset from relying on a single trusted vendor to embracing open collaboration and integrating components from multiple sources. That can be a big adjustment for engineering teams and management.
I can see that.
However, the long-term benefits and flexibility, reduced operational costs, and enhanced security are driving this complex transition forward, making it a strategic imperative for many companies.
So this convergence could lead to highly flexible and resilient industrial plants. Imagine facilities where you can easily swap out components, upgrade systems from different vendors without fear of incompatibility, or reconfigure entire operations with unprecedented ease. This significantly reduces downtime, simplifies maintenance, and allows for much quicker adaptation to changing market demands or new production requirements.
It really does.
Imagine a future where you can mix and match automation components from different vendors with ease, rather than being locked into one system. That's a huge promise. It's about empowering businesses with choice and flexibility, breaking free from proprietary constraints.
It's a game changer, potentially.
But a standard, no matter how brilliant, is only as good as its implementation.
Right.
Which leads us to effective engineering practices.
Absolutely critical.
Federico Fumagalli from J&W will cover effective engineering practices for IEC 61499, bridging theory and implementation.
Yes, and the workshop overview mentions the proposal of engineering methodology of IEC 61499 program. This is critically important. A brilliant theoretical standard will remain just that, theoretical, if practitioners don't have clear, well-defined, and effective methodologies for designing, developing, and deploying systems based on it.
You need the how-to guide.
Exactly. This session is vital for guiding engineers on how to translate the modularity, event-driven power, and distributed nature of IEC 61499 into reliable, maintainable, and scalable real-world applications. It's about codifying the best ways to actually build these new systems.
So it's about providing a clear roadmap, a set of best practices for how to actually engineer and build these systems.
Yeah.
Because adopting new engineering methodologies, especially with something as fundamentally different as IEC 61499, can be a significant challenge for teams accustomed to more traditional sequential programming approaches like ladder logic. The title Bridging Theory and Implementation itself really highlights this practical hands-on focus.
It does. It directly acknowledges that there's a gap between understanding the theoretical principles of the standard and mastering its practical application in complex industrial environments. This is precisely where the rubber meets the road. It's about making sure that the brilliant ideas behind the standard can actually be built into reliable working systems in the real world, ensuring successful adoption and unlocking its full transformative potential. Without robust engineering practices, even the most innovative standard risks falling short of its promise.
Makes sense. And speaking of practical benefits, one of the most exciting concepts that often comes up in these discussions is vendor-agnostic commissioning.
Ah, yes. A big buzzword, but important.
Mikhail Kolesnikov from Clovic, a company apparently at the forefront of collaborative and vendor-agnostic solutions, will present on vendor-agnostic commissioning Clovic, which aligns perfectly with the workshop topic of collaborative commissioning.
Right.
This sounds like a huge step towards simplifying one of the most complex parts of industrial setup.
The pain point of traditional commissioning is very real and often a significant headache for industries. It's typically a complex, incredibly time-consuming and expensive process.
Yeah, I've heard stories.
Frequently tied to specific vendors' proprietary tools and requiring intricate manual integration efforts. The concept of vendor agnostic is incredibly powerful here because it promises significant cost savings, vastly increased flexibility in choosing components, and a dramatic reduction in reliance on single suppliers.
And IEC 61499 helps how?
Its standardized function blocks are key facilitators here. They provide a common language and interface that allows components from different vendors to theoretically integrate and communicate much more smoothly.
So it means that instead of a new piece of equipment needing weeks or even months of specialized configuration from a specific vendor's engineers, you can, in theory, just plug it in. And it integrates relatively seamlessly because everything speaks the same IEC 61499 language, communicating through standardized function blocks.
That's the ideal scenario, yes.
This is truly about freedom from vendor lock-in, offering massive efficiency gains.
Exactly. This could dramatically reduce the time and cost associated with setting up, reconfiguring, and modifying industrial systems. It means businesses are empowered to adapt faster, bringing new capabilities online with far less friction and expense.
It fosters greater autonomy.
It does. It allows companies to select best-of-breed components from various suppliers, knowing they can work together. For industries facing rapid change, this agility is an invaluable competitive advantage.
The idea of breaking free from vendor lock-in is certainly compelling for any industry. What kind of tangible impact does that freedom have on a company's bottom line or its ability to innovate beyond just saving time on commissioning?
Well, beyond the obvious cost savings from reducing commissioning time, it fundamentally shifts a company's strategic options. When you're no longer tied to a single vendor, you gain greater negotiating power.
Leverage.
You can procure components globally based on quality and price rather than just compatibility. And crucially, you can integrate emerging technologies much faster. Think AI, new sensors, robotic. This accelerates innovation internally because you can rapidly prototype new production layouts or implement new automation strategies without being constrained by legacy systems or the slow pace of proprietary updates from one specific vendor. It allows for a much more dynamic and responsive business model.
Okay, that makes a lot of sense. This is where it gets truly transformative as we move into Section 5, Advanced Concepts and Real-World Impact. We've talked about the foundations. Now let's explore the cutting edge of what IEC 61499 enables.
The really exciting stuff.
First up, we have Oscar Miguel Escrig from University Jaume I discussing combining event-based control with IEC 61499, a novel approach to industrial automation.
This topic delves deeper into the inherent power and design philosophy of IEC 61499. We touched on event-driven earlier.
Right.
Event-based control fundamentally means that systems react to specific occurrences or triggers, rather than constantly running through rigid, continuous cycles, scanning inputs regardless of change. IEC 61499 is inherently event-driven. That's its core architectural principle. This natural compatibility makes it an ideal platform for implementing highly responsive, efficient, and dynamic control strategies in complex industrial environments.
So instead of a system constantly scanning all its inputs and outputs, burning energy and processing power whether anything's changed or not,
Yeah, the old scan cycle model.
it's more like a modern software application.
Yeah.
It only acts when you click a button or when new data streams in. It's not constantly doing things if there's no event to react to. This sounds like a much more intelligent use of resources.
Precisely. This capability is crucial for optimizing real-time processes, for sophisticated energy management, where actions are only taken when strictly necessary.
Energy savings, too.
Potentially significant, yes. And for advanced fault detection and recovery in incredibly complex industrial environments. By only acting on events, the system conserves computational resources, reduces network traffic, and can react instantaneously and in a highly targeted manner to changes. This leads to leaner operations, reduced energy consumption, and often more robust systems that aren't bogged down by unnecessary processing. It's about intelligence in action rather than constant blind activity.
Imagine a system that only acts when necessary, saving energy and resources, and reacting instantly to changes in its environment. That's the power of combining event-based control with IEC 61499. It's a smarter, leaner, and ultimately more sustainable way to operate.
Well put.
And the next set of presentations truly highlights the future: cyber-physical systems, plug-and produce, and low-code engineering.
The trifecta.
Pascal Pezendorfer from Schneider Electric will present on cyber-physical systems with the IEC 61499 standard, a modular framework for plug-and produce production.
Schneider Electric, a huge player.
Following this, Hilma Dafik, also from Schneider Electric, will discuss enabling plug-and produce and low-code engineering with IEC 61499 and Schneider Electric's EcoStruxure Automation Expert Platform.
This suite of topics from a major player like Schneider Electric is immensely significant because it brings together several transformative concepts, truly painting a picture of the factory of the future.
Okay, break it down for us. Cyber-physical systems first.
Right. Cyber-physical systems, or CPS, represent the deep integration of computation, networking, and physical processes. They are systems where the digital and physical worlds are inextricably linked. Think smart grids, autonomous vehicles, smart factories.
Okay.
IEC 61499 provides the essential language, the standardized framework, and the distributed architecture for these disparate physical and digital components to communicate and collaborate seamlessly. It allows smart machines to understand and react to their environment and each other.
Got it. And plug and produce, that's a truly revolutionary concept, isn't it?
It really is.
Instead of lengthy manual configuration processes that can take days or weeks, new machines or modules automatically integrate into a production line. Just plug it in, power it up, and it starts working. Much like plugging a USB device into your computer. Is that too simplistic?
It captures the essence, though the reality is obviously more complex. But yes, IEC 61499's modularity and standardized interfaces based on those function blocks are what make this a potential reality.
So how does it work?
Imagine adding a new robotic arm, a specialized sensor, or an entire new processing station to a production line. With plug-in produce enabled by standards like 61499, it could integrate itself with minimal human intervention,
Wow.
announcing its capabilities, maybe through standardized descriptions, and automatically establishing communication with other components using those IEC 61499 interfaces.
That radically reduces commissioning time again.
Hugely. It allows factories to reconfigure their entire layout on the fly to adapt to new product demands, enabling unprecedented flexibility. It moves manufacturing beyond fixed assembly lines to dynamic, reconfigurable production cells.
Right, dynamic cells. And then there's low-code engineering. What's that about?
This trend is about simplifying the process of programming and configuring automation systems. It uses visual interfaces, drag-and-drop components, and pre-built templates.
Making it easier for non-programmers.
Exactly. It empowers domain experts, people who deeply understand the manufacturing process, the chemistry, or the mechanics, but aren't necessarily professional software engineers to configure and deploy automation solutions. This significantly speeds up development and deployment times by democratizing access to automation design.
So you don't need an army of software engineers for every little change.
That's the idea. The combination of these three elements is incredibly powerful. Cyber-physical systems provide the intelligence, plug-in produce offers the physical agility, and low-code engineering provides the accessible tools to orchestrate it all.
And the fact that a major industry player like Schneider Electric is not only actively talking about these concepts, but vigorously implementing them with their EcoStruxure Automation Expert platform
Yeah, that's key.
shows real-world commercial commitment and robust adoption. This isn't just academic theory or a distant future vision. It's a commercial reality being built out and deployed in factories right now.
It signals that the industry is investing heavily in making this happen.
So, this suite of technologies promises the ultimate dream of the Agile factory, where new equipment slots right in, starts working immediately, and even non-programmers can tweak the settings and reconfigure processes.
It's like building with advanced modular components.
Or, yeah, like I said, super high-tech Lego for industrial production. That's incredible.
It is pretty revolutionary.
But for all this future vision and theoretical promise, we need real-world proof. We need to see it working out there.
Round truth, yeah.
And that comes from Meritha Gotas and Corrine Ralston from Kongsberg Maritime, who will share insights on IEC 61499 at Kongsberg Maritime.
This is a clear and highly significant industrial use case, as highlighted in the workshop overview. Kongsberg Maritime is a global leader in the maritime industry, dealing with incredibly complex vessel systems.
Ships and offshore platforms, right?
Exactly. These are environments often operating remotely in challenging conditions and frequently involving safety-critical applications where failure is simply not an option.
Extremely high stakes.
Absolutely. Their adoption of IEC 61499 is a powerful validation of the standard's robustness, scalability, and suitability for the most demanding industrial scenarios, if it works reliably there.
It can probably work anywhere. That's a huge endorsement.
Mhm.
What are some of the potential applications or benefits we might see from using IEC 61499 in the maritime space?
Well, think about the immense complexity of a modern vessel. Sophisticated engine control systems, advanced navigation and dynamic positioning systems that hold a ship in place precisely, even in rough seas.
CDP systems, yeah.
Highly intricate cargo handling systems, and increasingly the development of autonomous vessel operations.
Autonomous ships, wow.
These are all inherently distributed systems that demand extreme reliability, high availability, and the ability to be reconfigured or upgraded without taking the entire ship offline for extended periods in dry dock.
Okay.
IEC 61499's distributed control capabilities are particularly valuable here, allowing for more resilient, reconfigurable, and efficient control systems on board. For example, it could enable easier integration of new sensor arrays for enhanced situational awareness, or modular upgrades to propulsion systems, or maybe implementing advanced diagnostics that predict failures before they happen, all while maintaining the highest safety standards.
So it's one thing to talk about standards in a lab or a research facility, but when a global leader like Kongsberg Maritime embraces it for their ships, where the stakes are incredibly high for both safety and operational efficiency.
Yeah.
You know, it's not just making waves, it's genuinely transforming how critical operations are managed globally. This provides concrete, undeniable proof of the standard's practical benefits and its scalability beyond traditional factory floors into some of the most demanding industrial environments on Earth.
It's a testament to the fact that the principles of flexibility, modularity, event-driven control, and distributed architecture are universally applicable and profoundly beneficial across diverse industrial sectors.
They offer solutions to challenges that are common, albeit in different guises, across various industries.
Exactly. The underlying needs for agility and efficiency are widespread.
Wow, what an insightful journey we've taken today. This deep dive truly has shown us that IEC 61499 is not just another technical specification, it feels like a foundational cornerstone for the next generation of industrial automation.
I think that's fair to say. We've explored its fundamental power as an international standard for creating flexible, event-driven, and distributed control systems.
Right, core concepts.
We've identified the key proponents and thought leaders, like universalautomation.org, who are actively building a community and a vision for open automation.
The ecosystem builders.
And we've highlighted the crucial role of foundational open source infrastructure, such as Eclipse Fortiac, which, with 18 years of continuous development, demonstrates incredible maturity and stability.
That 18 years really stuck with me.
It's significant.
And we've seen how innovative engineering practices, like effective methodologies and vendor-agnostic commissioning, are absolutely crucial for bridging the gap between theory and practical application.
Making it real.
We then dove into the advanced concepts being discussed at the ETFA 2025 workshop, from combining event-based control for leaner, smarter operations to the game-changing potential of cyber-physical systems, plug-and-produce manufacturing, and low-code engineering.
The future stuff.
All being spearheaded by major industry leaders like Schneider Electric, bringing these visions to commercial reality.
Most importantly, we've brought it all back to real-world impact with concrete, compelling examples like Kongsberg Maritime's adoption, proving that IEC 61499 is not just a futuristic idea, but a present-day reality actively driving efficiency, innovation, and adaptability across diverse and demanding industries.
From factories to the high seas.
Exactly.
We truly hope this deep dive has provided you, our listener, with a comprehensive yet accessible understanding of a complex critical technology. You now have, hopefully, a significant advantage in grasping the future of industry, knowing the key players, the foundational technologies, and the groundbreaking applications that are not just on the horizon but already be implemented today.
This standard is truly enabling a new era of industrial agility and intelligent operations. It's a fascinating space to watch.
It really is. And as IEC 61499 continues to drive the plug-and-produce revolution and enable truly intelligent, flexible automation, consider this. What everyday products or services around you will be the first to truly benefit from this new era of adaptable, software-defined industrial control?
Good question.
How might our daily lives implicitly change when the factories, energy grids, and maritime systems behind them become this agile and smart, dynamically responding to our needs and the world's challenges with unprecedented speed and efficiency?
It's a thought that points to a future where adaptability and efficiency are truly embedded at the core of how everything is made and managed, impacting everything from your next car to the electricity powering your home, perhaps in ways we don't even fully anticipate yet.
Something profound to ponder as you look around at the increasingly connected and automated world today. Thank you for joining us on the Deep Dive.
Thanks for listening.
We'll see you next time.